In the previous video, we looked at what happened when we changed the second constraint of our example on linear programming from x plus y is less equal to 15 to x plus y is less equal to 12. And we saw that the optimal solution changed from 7 and 8 to 8 and 4. All right, and we could do it quickly using the information in the final tableau of our simplex method. Now let's see what happens when we change that same constraint to x plus y is less or equal to 18 this time. All right, so we'll do the same work. So delta 2 is the new limit minus the old limit. And in this case, it's 18 minus 15, which is 3. All right, and then we're going to use exactly the same formula. Let me not write these parts because the deltas are 0 anyway, so it's a bit of a waste of time. So my variables were s1, y, x, p. 2, 8, 7, 22, that was my constant. That was my current 2, 8, 7, 22. That was my current optimal solution. And then we're going to put the constants, the column of S2 here. So minus 4 thirds, 4 thirds. So minus 4 thirds, 4 thirds. I had minus 4 thirds, 4 thirds, minus a third, and 2 thirds. Let's double check. Yep, that's right. I'm going to place my value 3 right here, and let's add it up to see what we get. 2 plus 3 times minus 4 thirds, that's 2 minus 4, I get minus 2. We're cooked. Already I know this is not going to work out. I'm not going to get an optimal solution. Let's still compute the rest of it so we could see exactly what's going on in the sketch. So 8 plus 4, that's 12. That one was fine. 7 minus 1 is 6, and 22, that's 2 thirds, right? So 22 plus 2, that's 24. Right, so since S1 equals minus 2, that's not allowed. And so post-optimal analysis does not work. Here. It worked in the last one because I got all positive values. It doesn't work here because I'm getting a negative for S1. Let's see what's going on. All right, so my region, I haven't changed the first. Oops. I still have y equals 10, and I haven't changed this one either. So I'm doing this so I get the slope right. Sorry for cheating. All right, this one is 4x plus y equals 36. All right, so my new second constraint is x plus y is less or equal to 18. So 18 about here, 18, 14, 16, 18 about here. So this is my new constraint. First thing you should notice is the region has changed, right? The shape is different. In fact, the purple curve doesn't touch the region any longer. The real issue is when we do post-optimal analysis, we're assuming that the optimal solution will happen at the same intersection of two curves. So this was constraint 2 and constraint 3. So if we look at these two curves, we're getting this point, which is 612, according to our computation. Right here we get x is 6 and y is 12. So it's telling us that these curves intersect at 612, but you can see that can't be our optimal solution because we're not respecting this constraint. In fact, that's what this is telling us. We're getting minus 2, and that means that we're off by 2. We went too far by 2. So as soon as one of the basic variable that you're getting when you compute this, as soon as one of them is negative, that means the region has changed, the shape is different, and the optimal solution is no longer at the intersection of the two things, the same two constraint, the same two boundaries. But you could see if I move it slightly, if I move it a tiny bit, it's still going to be there that you'll have the optimal solution. But if you move it a lot, if you move it past, if I move it right here past another corner, then it cannot be the optimal solution any longer. All right, so for a problem like this, if you want to know what the solution is, you'd have to start from scratch with this in your initial table.